Hi everyone, my name is Maurício. I'm one of the authors of Fast Self-Attentive Multimodal Retrieval. Okay, this is a basically core task for computer vision. The idea is to retrieve image from text and vice versa. As you can see in the example, you can, given an image, you can generate a sentence, a captioning, and typing in sentence, you can retrieve an image in a search tool, for example. The idea is to find a common semantic space for both modalities. You pass the image through a neural net and a caption as well, in order to discover the correspondences between them. Normally, the approach uses recurrent neural networks with word embeddings, but they are somewhat complex and slow, and finding a replacement would be useful to improve speed. So we propose the use of self-attention, which enhances relevant textual information while suppressing relevant data. Our contributions are SIM, which is 3 methods that we proposed, and self-attentive embeddings for aligning modalities. We replace RNNs with convolutions and self-attention mechanisms, and we basically beat the state of the art in most cases, and with a much, much faster approach. So let's go through them. SIM. First, the self-attention module is basically 2 layers of a 10-age activation function at the first layer and a softmax in the second. It basically weights the features of the word embeddings through the time. And let's go through our first method, which is the SIM-C, Convolution Approach. It basically passes through to different convolutions, convolutions with different filter sizes. It passes it, and the word embeddings itself, passes it through the module of self-attention, concatenate the results, and get the last feature representation of the sentence. The second method is SIM-E, which uses the self-attention module directly on the word embedding. The third one is a GRU Baseline. So we use the GRU on the embeddings, and the result we pass again through a self-attention. So let's go through the experiments. We use the COCO dataset with 100,000 images and 5 captions for each image. The measures are the recall at k at 1, 5, and 10, and the mean ranking. Okay, the results. We basically outperforms all the baselines in almost all cases for image to text and text to image, with one exception, that it's the R at 1 for image to text retrieval. But the two-way net that outperforms closely our method uses more than 200 million parameters. For training process, our methods are 3 times faster than the baselines, as you can see in the chart. And for the testing, our methods that don't use a GRU, they basically scales very well with the sentence length. And okay, thank you. If you have any other questions, see you in the poster.